Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming. A recent revelation has sparked intrigue and wonder among scientists and space enthusiasts alike. Renowned science communicator Bill Nye caused a stir when he revealed that Voyager 1 had detected 300 massive objects in space. This revelation has not only piqued our collective imagination but also sparked profound questions. So, what are these objects, and where do they come from? Come along as we unravel the mysteries hinted at by Voyager 1's astonishing revelation. For nearly 50 years, the Voyager missions have given us some of the earliest and most remarkable views of our solar system's wonders. Surprisingly, these missions were not built to last so long. In the 1970s, Michael Minovich had a breakthrough idea. A spacecraft could use a planet's velocity to propel itself further into the solar system. Initially planned to last only 5 years, the Voyager mission has far surpassed these expectations. Voyager 1 and Voyager 2, launched just weeks apart in the summer of 1977, were first set to explore Jupiter and Saturn. They achieved this mission by successfully studying these gas giants, but they didn't stop there. Voyager 2 went on to make the first-ever close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of 4 planets earned the mission the name Voyager Grand Tour. Instead of ending their mission, the resilient Voyager spacecraft set their sights on an even more ambitious goal: exploring deep space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, gathering essential scientific data from the far reaches of the cosmos. In a groundbreaking announcement in 2013, NASA revealed that Voyager 1 had officially entered interstellar space. Interstellar space is the region between stars, beyond the influence of the Sun's particles and magnetic fields. It's like moving from a busy solar system into a peaceful, star-filled wilderness. The Voyager story continued in 2018 when Voyager 2 also entered this vast region, 17.7 billion kilometers away from the Sun. Remarkably, Voyagers 1 and 2 are the only spacecraft to have ventured into interstellar space. These pioneering spacecraft have been studying how the interstellar medium interacts with the solar wind from our Sun. NASA's Voyager 1 and 2 spacecraft have been our primary source of information regarding the heliosphere, a protective shield enveloping our solar system. The heliosphere is shaped and adjusted by the solar wind, a continuous stream of charged particles emitted by the Sun. Voyager 1 and 2 have acted as our cosmic reporters, sending back valuable insights about this celestial shield. Where does all this information converge? At the heliopause, the official boundary of our solar system, marking the transition from the solar wind to the vast expanse of interstellar space. NASA's Voyager spacecraft has provided valuable new knowledge about interstellar space. One significant finding is that cosmic rays, mysterious particles, are 3 times more intense beyond the heliopause compared to within the protected area of the heliosphere. This difference is like comparing the tranquility of a backyard to the bustling activity of a busy street. However, there's more to this cosmic drama. NASA's experts didn't stop with Voyager discoveries. They integrated data from subsequent missions with Voyager's observations, creating a comprehensive portrayal of our Sun and its complex interaction with the surrounding interstellar space. In a grand cosmic performance, NASA scientists made a surprising revelation last year. Voyager 1 captured a low humming sound that matched the vibrations detected in small amounts of gas floating in the vast emptiness of interstellar space. Nicola Fox, the leader of NASA's Aerophysics Division in Washington, D.C., stressed the importance of the Voyager missions. In her words, over the past 46 years, the Voyager missions have been crucial in providing us with this knowledge and have changed our understanding of the Sun and its effects in ways that no other spacecraft can. Now that's quite an adventure in space. Voyagers 1 and 2 rely on a power system fueled by plutonium. However, as the plutonium ages, it produces less heat, causing the Voyagers to lose power. Facing this cosmic challenge, NASA had to make tough choices, shutting down non-essential systems and even some initially deemed necessary. The heaters meant to keep instruments warm in the freezing expanse of space were turned off. But here's the surprise: despite the odds, all 5 instruments have been functioning well since 2019, defying expectations. NASA experts are puzzled, wondering how the Voyagers are still operating in temperatures that would normally freeze other spacecraft. It's a mystery that deepens the remarkable legacy of these brave space pioneers, adding another layer of wonder to their enduring journey. The outer edges of our solar system are surprising astronomers with unexpected behavior. The heliopause, which acts as a boundary between our sun's influence and the space between stars, is not staying still. Instead, it's moving and creating strange angles, leaving scientists amazed and puzzled. This idea of the heliopause changing shape isn't entirely new. For the past 10 years, researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite have noticed the heliopause's tendency to change. These spacecraft are incredibly important as they give us direct measurements of these cosmic borders, even though it's just at one specific spot in space and time. Dr. Eric J. Zarin, a space physicist at Princeton University, shared some exciting insights in an email to Vice. He mentioned how IEX, another satellite, is adding valuable data to help scientists make better predictions about the heliopause's future movements. Now here's where it gets more interesting. Recent studies have challenged what we thought we knew. IEX noticed a strange brightening of energetic particles in 2014, suggesting some irregularities in the heliopause. However, these irregularities didn't match our existing models, almost like a surprise twist in a story. Moreover, researchers saw significant changes in the heliopause's position in a short time after studying data from Voyager 1 and Voyager 2. This movement might explain why these two probes reached interstellar space in 2012 and 2018, respectively, with a big gap in between. These unexpected behaviors are not just confusing. They contradict what we thought we understood about the heliopause. In a recent article in Nature Astronomy *, scientists referred to these discrepancies as entry-speaking, meaning they are puzzling and could cause some debate in the scientific community. But don't worry, the search for answers continues. Scientists are eager to learn more from NASA's upcoming Interstellar Mapping and Acceleration probe, scheduled to launch in 2025. This advanced satellite promises to reveal more secrets about the outer reaches of our solar system. Until then, we can only wonder about the mysteries waiting for us beyond the heliopause. In May 2023, Voyager 1 experienced an unusual event during its regular operations. The Voyager spacecrafts are now so distant that it takes about 22.5 hours for a radio signal traveling at the speed of light to reach Voyager 1 from Earth, while Voyager 2 requires nearly 19 hours. Each day, these brave probes move another 3 to 4 light-seconds away from us. NASA's Deep Space Network, consisting of 3 tracking complexes located strategically around the world, serves as their lifeline, ensuring continuous communication even as Earth rotates. As our spacecraft venture further into space and time, their signals become faint whispers. The Earth's bustling noise from radios, TVs, cell phones, and other forces makes it quite difficult to pick up these faint signals. Despite their faintness, these whispers align with astronomers' expectations as the Voyagers move into the interstellar part of their mission. This mission, a massive scientific endeavor spanning around 10,000 workers, is widely regarded as one of our species' most significant explorations. Interestingly, it almost didn't happen. The Voyager mission was a stroke of luck in celestial mechanics. Initially, Michael Minovich discovered that spacecraft could gain speed from a planet to move away from the Sun. Building on this, Gary Flandreau demonstrated that probes launched during the late 1970s and 1980s could utilize a special alignment of outer planets, using gravitational assists to travel faster. This revelation made Neptune, situated at the solar system's edge, reachable in just a dozen years instead of the anticipated 30. NASA seized this opportunity, although budget constraints led to scaling back the grand tour of the outer solar system. Consequently, instead of an extensive exploration, they opted for a more affordable visit to Jupiter and Saturn, still amounting to a $250 million journey. Researchers were hopeful for a detour to Uranus and Neptune, banking on Voyager 1's success at Jupiter and Saturn to adjust Voyager 2's trajectory for these planets. Let's delve into the equipment. The twin Voyagers were equipped with advanced instruments like cameras, infrared and ultraviolet spectrometers, sensors for mapping cosmic particles like charged particles and cosmic rays, along with a photopolarimeter and a magnetometer. Powered by nuclear energy, these spacecraft were initially expected to operate for about 5 years. However, they exceeded expectations, extending their lifespan tenfold. Over time, the Voyager mission has transformed into a legendary expedition to the outer planets and beyond. It's not just a scientific endeavor but a symbolic journey, blending myth and science. The mesmerizing images of distant worlds captured by these spacecraft turned the mission into a historic quest into the unknown. And then there's the Golden Record, a standout feature. Each Voyager carried a phonograph record filled with images, music, and sounds representing Earth, including greetings in 55 languages. It served as a cosmic message to any intelligent beings in the Milky Way, a hopeful communication across vast distances. The thought of extraterrestrial civilizations encountering these messages stirs excitement, offering us a glimpse of galactic recognition and potential immortality. The Voyager mission symbolizes our profound curiosity about the cosmos, resonating with participants and observers alike, reflecting our collective desire to understand our cosmic significance. For more than 10 years, the diligent work of these twin spacecraft has allowed humanity to explore the mysteries of space between stars. The probes sent by NASA have not only given us valuable knowledge about our solar system but also uncovered the unusual and surprising aspects of space beyond our Sun. Let's break it down. Despite appearing calm as a glowing ball of light, our Sun is a dynamic nuclear furnace, zooming through the galaxy at an incredible speed of 450,000 miles per hour. The Sun is surrounded by twisted, tangled magnetic fields as it moves around the center of our galaxy. Constantly, the Sun releases a flow of electrically charged particles called the solar wind. Now here's where it gets interesting. The solar wind doesn't just vanish into space, it clashes with the interstellar medium, which is a mix of remnants from old star explosions floating between stars. Think of it like oil and water colliding, they don't blend perfectly. Instead, the solar wind creates a protective bubble within the interstellar medium called the heliosphere. Thanks to data from the Voyager spacecraft, we now understand that this heliospheric bubble stretches a massive 11 billion miles from the Sun at its leading edge. It wraps around the Sun, all 8 planets, and many objects orbiting far from our star. This heliosphere isn't just there for decoration, it acts as a shield, safeguarding everything inside, including our fragile DNA, from most of the galaxy's intense radiation. Picture it as a protective shield ensuring the safety of our solar system amidst the vastness of space between stars. To solve these cosmic mysteries, we need to fully grasp the heliosphere. That's why NASA is like cosmic tech support, ensuring these distant explorers stay operational by sending software updates across immense distances. It's a bit like performing surgery on a patient located an astonishing 15 billion miles away, not your typical task for a Monday morning. Updating Voyager's software isn't a simple task, it involves sending new instructions directly to the spacecraft's computers, which are programmed to understand the most basic form of programming known as machine language. This means the instructions must be written in a language that the hardware can understand without the help of an operating system or advanced programming tools. To handle this challenge, NASA engineers use a combination of creativity and resourcefulness. They use assembly language, a programming language similar to machine code, to create the update instructions. This approach gives them direct control over the hardware, ensuring the code runs as efficiently as possible. They also use pseudocode, a simplified set of commands that automate repetitive tasks without using too much memory. These software updates are not just about fixing bugs, they are crucial for the survival of our brave spacecraft. Over the years, these updates have solved various problems, from fixing malfunctioning parts to addressing issues with memory. For example, a software update once saved Voyager 1 from a potential disaster when a hardware component stopped working. The update activated a fail-safe mechanism, giving the spacecraft the boost it needed to continue its mission in space. The Voyager missions were not just routine journeys, they were the starting point for numerous interstellar adventures. These missions not only made groundbreaking discoveries but also inspired further exploration into the unknown realms of space. When the Voyager spacecraft took a closer look at Jupiter, it unveiled the planet's intricate nature. This discovery sparked great enthusiasm at NASA, leading to the launch of 2 significant missions, Galileo in 1989 and Juno in 2011. You can think of Voyager as the precursor to these major space missions. But that's not all. Voyager's exploration inspired the renowned Cassini mission to Saturn. Jonathan Lunin, a prominent planetary scientist at Cornell University, credits Voyager 1's detailed flyby of Titan, one of Saturn's moons, as the driving force behind Cassini's remarkable mission. Cassini even deployed a probe named Huygens onto Titan's surface in 2005, capturing stunning video footage. Voyager 2 also made significant contributions. It initiated studies into the icy giant planets, not only within our solar system but also in distant star systems. Consider this. Many of the exoplanets we've discovered so far share similarities with Neptune and Uranus in size, and Voyager 2 played a role in this cosmic exploration. Now, fast forward to the present day, NASA continues to build upon the legacy of Voyager. The Dragonfly mission is scheduled to land on Titan, Saturn's largest moon, in 2034. The Europa Clipper mission is preparing to investigate Jupiter's moon Europa, first observed by Voyager, starting in 2030. Additionally, the National Academy's Planetary Science Survey proposed a $4.2 billion mission to Uranus with an orbiter and probe in the 2040s. This mission represents a significant encounter with the enigmatic ice giant and its moons, all tracing back to Voyager 2's brief encounter with the Uranus system in January 1986. Nearly 5 decades have passed since Voyager 1 and Voyager 2 began their incredible journey through space, but their impact is still felt today. These spacecraft set off a chain of curiosity and discovery that continues to unfold. Here's the latest update. Both Voyager 1 and Voyager 2 are still communicating with NASA's Deep Space Network. This network, initially meant for communicating with Voyager 2 during its missions at Uranus and Neptune, is still receiving instructions and sending back data to Earth. This enduring connection is quite remarkable. Estimation Crimagis, the lead scientist for the Voyager 1 and 2 missions, shared these updates during a recent news conference. He mentioned that we are still collecting valuable data from the Voyager spacecraft, and the plan is to continue this interstellar exploration for another 5 or 6 years. However, by the mid to late 2020s, the scientific instruments on these spacecraft will be turned off, and they will become silent and inactive. Nevertheless, their journey into the vast unknown of space will continue indefinitely. Crimagis, who is in his 80s, humorously remarked that he hopes to outlast the Voyagers, although he's unsure if that will happen. In about 300 years, both Voyager 1 and Voyager 2 will enter the Oort cloud, a region filled with comets surrounding our solar system. After another 30,000 years, they will depart from our solar system and orbit the center of the Milky Way for millions of years. Although their scientific missions will wind down, the Voyagers' incredible odyssey through the cosmos is just beginning. While the Voyagers continue their journey, NASA's Hubble Space Telescope, an experienced observer at nearly 33 years old, is still making stunning discoveries. In a recent image, Hubble captured the radiant glow of a distant spiral galaxy called MCG plus 01-12-041, located about 275 million light-years away. This galaxy is unique, with its 2 spiral arms and an active galactic nucleus at its core. MCG plus 01-12-041 falls into the category of Type II Seyfert galaxies, known for their bright cores but less intense compared to quasars. It's like a cosmic show, with galaxies revealing their secrets, each adding to our understanding of the vast universe. MCG plus 01-12-041 stands out because of its unique light. In astrophysics terms, it's a bit of a surprise. Normally, when we look at the light patterns from atoms and molecules, they follow certain rules, but in space, there are lines in these patterns called forbidden emissions that don't play by the rules. It's like they're rebelling in the cosmic sense. Why are they called forbidden? Well, on Earth, according to the neat rules of quantum physics, these emissions are so unlikely that we usually don't pay attention to them. But in the active center of a galaxy, things are different. The forbidden light gets a chance to shine toward us, and that's what the Hubble telescope captured in a photo. This picture, taken by Hubble's advanced camera, shows MCG plus 01-12-041 as the star of the cosmic show. There are also 2 bright stars in the foreground, one blue and one red, that add some sparkle. If you look closely, you can also see more distant galaxies in the dark space background. It's like a stunning piece of celestial art, reminding us of the Hubble telescope's ongoing contributions to our understanding of the cosmos.